Assalamu alaikum everyone. My name is Bakir Ali, and in this video we will discuss topical questions of work energy and power topic. Okay, so let's start with the recent most questions of 2025. In question 1, what they're telling us, there is a proposed flying machine that would work like a screw to lift the pilot into the air. This is the machine that they are talking about. The screen is rotated by the pilot. The machine and the pilot together have the mass of 120 kg. So we have the mass, which useful output power must be pilot provide to move vertically upward at a constant speed of this. Okay, so you have to find power. You have given mass. You have given speed. 2.5 meter per second. Okay, so if you have to move this machine vertically upward, how much force you have to apply that will be at least equals to its weight. Okay, so the force we can also find that will be equals to weight, that is mg. M is given 120, g is 9.81. Okay, so what relation for the power we can use? We have a relation for the power that P is equals to F into V. Okay, so we can use this relation. We have F, we have V, and we can easily find it. F is mg, so 120 into 9.81 into the speed, that is 2.5. Solving this will give you 2943 units of powers are watt. Okay, so when you round it off, it will be the D option. In the next question, an object is falling uniformly in a gravitational field. Which two quantities are sufficient to calculate the change in gravitational potential energy? So first you need to know what the gravitational potential energy is. Gravitational potential energy, if you remember from the IGCSE, it is mgh. Okay, so what you need to find, if you see this thing as a whole, this is the weight mg and this is the vertical displacement, so it's option D. So you need weight and change in vertical displacement. Okay, in the next question, there are 3 points x, y, and z are on a rough horizontal surface. Okay, they, it look like it's at a vertical height, but it's not at a vertical plane, it is on a horizontal plane. Okay, so they all x, y, z, all the 3 points are on the same height, they are on the ground. Okay, so you're not changing the height when you're moving from x to y or x to z. You are moving on a ground, on a horizontal plane. Okay, so the box P pushes across the surface from x to y and then from y to z. So P is moving from, let's use this color for the P there. It move like this and then it will move there. Okay, this is the journey of P. And for the Q object, okay, what they're telling, the distance from x to y is 3. The burden against the friction in moving a box from x to y is 150. So I can say work from x to y is 150 joules. That is given. The work done against the friction in moving the box from y to z is 200. So you have work from y to z as well. That is 200 joules. Okay. Then they are telling you about an identical box Q is pushed straight from line X to Z. It's moving X to Z. Okay. Again, keep in mind they all are at the same height. Okay, it's on a horizontal plane, so height is not changing. So this is for the Q. So for Q is moving from X to Z. The magnitude of frictional force between the box and the surface is constant. Okay, friction is constant all over. How much extra work is done against the frictional force in moving P than moving Q. Okay, for the Q, the work done is simply from X to Z. So if you have to find extra work, then you have to find the difference. So work for P minus work for Q. Okay. So work for P, if you see P first move from X to Y, then Y to Z. So the work for P is simply work from X to Y plus work from Y to Z. That will give you 150 plus 200. That thing will give you 350. So this is 350. And work from for the Q is work from X to Z. Okay. So if you have to find work from X to Z, so this is the main concern. We have to find work from X to Z. What you need work is force, and that is the frictional force. In that case, let's call it small f, multiply by the distance, and we know the distance traveled is X to Z. Let's call it a D. This thing is D. We have to find D. Okay, what I know from the Pythagoras theorem, what I can say that D can be equals to this side square plus this side square under the root, right? So D can be equals to under root 3 square plus yz square. But I don't know the yz as well. Okay, so how we can find the yz? You have to look at what information you have. Okay, we only know the burden for the yz. Okay, we know the burden for the yz, that is 200. That's it. Okay, so let's try to find out the force first, the frictional force. We can find the frictional force from the information of X to Y. So if you say work from X to Y is frictional force into the 3, so frictional force will be equals to work xy divided by 3. Work xy is basically 150 divided by 3 give you 50 newtons. So now we have the frictional force that is equals to 50 newton, and it is same for all of the parts. It's given in the question. Okay, now I can find the d. Now I can find the yz. So to find yz, this yz, I know the burden of y to z is frictional force, that is 50. We have just calculated, multiply by the yz. So yz can be written as the weight, the burden from y to z is 200 divided by the friction, that is 50. It is equals to 4 meter. So this thing is 4 meter. Okay, so now you have this thing as well. You can put it here. It is 4 meter. So 3 square is 9, 4 is 16, that will give you 25, and that will be equals to 5.0 meter. So now we know the D as well, that is 5.0 meter. Okay, so now we can find the work from X to Z. Force is 50, distance traveled is 5, that will give you 250 joules. Now you can put this value here. So this will give you 350 minus 250, 100 joules. Okay, so that is a extra work that is done by the P as compared to Q. Okay, so it is equals, option A is correct. Let's move back to the next question. The momentum of the car M increased from P1 to P2. What is the increase in kinetic energy of the car? Okay, so they are relating momentum with the kinetic energy. First thing, you need to know the relation between them. Okay, we know kinetic energy is equals to half mv square, and we know P is equals to mv. If you have to relate both of them, you have to make kinetic energy, you have to drive kinetic energy in terms of momentum. Okay, so what I can do, if I multiply and divide mass, it's m multiplied and divided with 1 by 2 mv square. It will give me m into v whole square. I can write divided by 2m. M into v is momentum, so it can be written as momentum divided by 2m. So I know kinetic energy is p squared divided by 2m. Okay, so momentum is changing from p1 to p2. So if the change of momentum is this, the kinetic energy final minus initial will be p2 square divided by 2m minus p1 square divided by 2m. 1 by 2m can be taken as common. It will give you p2 square minus p1 square. Okay, so it's option A we have. Okay, in the next question, a parachutist is falling at a constant terminal velocity. Which statement is correct? Okay, it's the conversion of energy, and they're telling you the velocity of the parachutist is constant. So if the parachutist velocity is constant, it's indicating there will be no change in kinetic energy of parachutist. Okay, so in a option, they are telling gravitational potential energy converted to kinetic energy of the air. It can be done. Gravitational potential energy is converted into kinetic energy of the parachutist. No, that is not possible because parachutist velocity is constant. So this statement is incorrect. We have to choose the incorrect one. Okay. Next question. A ball of mass 2 kg travel through horizontal speed of this. You have a mass, you have a speed. A ball hits a cushion and come to rest over a horizontal distance of this. You have a distance. What is work done by the cushion on the ball to bring it to the rest? Okay. So as the ball was moving, so we know that ball have kinetic energy, that is 1 by 2 mv square. Same amount of work is required to stop it. So this should be equals to the work done to stop it. They should be equal, right? So you can simply find its kinetic energy and that will give you the work. Mass is 1.2 and velocity is 3.0 square. So it will give you 5.4 joules. It's a pretty simple question. And the next question, they are telling us a box of mass 4.9 kg is pushed at a constant velocity from point P at the bottom of the inclined plane to the point Q at the top. Okay, this thing is important. Keep in mind, it's a constant velocity. Okay, you have the mass. The box is pushed by a force of 64 Newton acting parallel to the slope. The slope is inclined at 20 degree to the horizontal, and the box moves through a vertical height of this thing. What is the word done against the frictional force acting on the block between P and Q? So first you need to understand the scenario. The box is moving from here. How it is moving from here? You are doing some work done. When you do the word done on the box, that word done will change. Some of it will change into the potential energy because it's gaining height. Plus some of them will be against the friction to overcome the friction, right? So why we are not involving the kinetic energy? Because velocity is constant. So as velocity is not changing, there will be no change in the kinetic energy. So I can say work done will be converted into gpe plus work against friction. Okay, let's call this thing wf. Okay, I'm calling work against friction WF. Okay, so we know work done against friction, then this thing will go on the left side. No, this will remain here. Sorry, this GP will go on the left side and it will remain there. So WF will be equals to work minus GPE. Work done is force into displacement minus mgh. Force applied is 64, it is given. Distance traveled is, okay, so we don't have the distance traveled. Okay, if you remember the definition for the work done is the force multiplied by the distance traveled in the direction of force. So what you need, you need this distance. Okay, so this thing is, let's call it d. So if you see this thing, this is a triangle. We can use a basic trigonometry. We have this angle, we have this angle, this is perpendicular, this is hypotenuse. So if you use a sine function, sine theta is perpendicular over hypotenuse. Okay, so you can write as sine 20 degree is equals to 5.8 divided by d. So d is equals to 5.8 divided by sine 20. Okay, so we can put this thing here, 5.8 divided by sine 20. Okay, and minus mgh. So when you minus, mass is 4.9, g is 9.81, and height is 5.8. Okay, when you solve this thing, it will give you 806.51, that is 810 nearly. Okay, so option B. In the next question, which expression gives the efficiency of a system? You need to remember the definition of the efficiency. Efficiency is useful output power or the output energy divided by the total input. Okay, energy or power, it can be defined both the ways. Okay, so in this thing, the option C is correct. Useful energy output divided by total energy input. Okay, in the next question, four identical uniform blocks are spread on the table. Each block has a mass of m and a thickness of h. How much work is done on the block in stacking them on the top of one another? Okay, so you have to place them in this way, and they are originally like this. I've shown there. Okay, so first block is there. You don't have to move this one. What you have to do, you can stack this one on it. Okay, so when I'm going to place this thing here, let's suppose, let's color them. This one will be here, and this one have to come here. How much energy it will gain? It will gain mgh. Okay, this is the amount of work you have to do. Okay, now you have to place this one at this point. How much height it has to cover? Okay, this one, this is mg 2h height, right? Okay, and the last one, that is this one, it has to be placed there. How much height it has to cover? It is mg 3h height, right? So this is the total burden that you have to do. So total work is, for the first block you have zero burden. For this you have mgh. For this you have 2 mgh. For this you have 3 mgh. Okay, so it is 0 plus mgh plus 2 mgh plus 3 mgh. So that will give you 6 mgh. The next question, an electric motor uses 1.7 kilowatt of power when operating normally. So this is power input that is given. The efficiency of the motor is this. What is the useful output power? Okay, you have to tell useful output. We know efficiency is P output, useful output divided by total input. So if you have to find P out, the efficiency multiply by the P in. Efficiency in percentage, if you have to convert 53% into fraction into decimal, that will be equals to 0.53. You have to divide it by 100, okay? So 0.53 multiplied by the input power. Answers are all in kilo, so I'm not converting. Input is 1.7, okay? So your answer will also be in kilo. When you multiply both of them, 0.53 multiplied by 1.7, it will give you 0.901. And as we haven't converted the unit, so our answer will also be in kilowatts, okay? So it's option B. And next question, a ball is released from the rest and fall vertically to the ground. The kinetic energy of the ball varies as the height of the ball above the ground changes. Air resistance is negligible. Which graph shows the variation of EK with the H? So if you consider, let's suppose this is the ground, object is at this point, it's moving down. Okay, and this is the total height. Okay, so this is the starting point. At this point, the height is maximum. Kinetic energy will be minimum. It's starting from the rest, so it will be zero. And keep in mind, we are just ignoring the air resistance, okay? When it hits the ground at this point, it's going to hit the ground. H is minimum, that is zero. Kinetic energy will be maximum, right? Okay. Now, what is the relation we have? The gain in kinetic energy is basically loss of potential energy. So kinetic energy is Ek as they have shown in the question. It's represented by Ek and this is mgh. Okay, we know the mass of the object is constant. G is also taken as constant for the Earth. So Ek is proportional to height, change in height. Okay, change in height. So if you see, the kinetic energy is increasing when it's moving down. But what is happening with the height? What is the change in height? The change is negative, okay, because it's moving down. So it will be a straight line because they are proportional to each other. As the height, as the object is moving down, in the same as the height is changing, they both are proportional. So the change in the height is directly proportional with the kinetic energy. But this change is negative, so the slope will be negative. Okay, so its option is D. At a maximum height, kinetic energy is minimum, and at a minimum height, kinetic energy is maximum. The next question, an object travel with a speed of 10 meter per second has a kinetic energy of this much. Okay, let's call it V1. Let's call this kinetic energy 1. Okay. The speed of the object is increased to this. Let's call this V2. What is the new kinetic energy of the object? Let's call this KE, kinetic energy. New, it's called it 2. Okay. So if you have to find the kinetic energy, new, that I call just 2, is equals to half mass into V2 square. Okay. So we have V2, but we don't have the mass. So what we can do, we can use this information because mass will remain constant. So this will be equals to kinetic energy, that is 1500 is equals to half mass into velocity square. So you have to find mass. Mass will be equals to 2 into 1500 divided by 10 square. Okay. So when you solve this thing, mass you will have 30 kg. Now we can put this thing here. 30 into velocity is 40 square. That will give you 2400 joules. Okay, it's option C. Okay, the next question, which relationship is used in the derivation of equation P is equals to F into V? Okay, if you remember the relation, what we have done, P is equals to power is work over time. Work is F into D divided by T, and we call this thing as V, displacement per unit time. So this is option A. They just have changed, they just rearranged this relation, but it's the same thing. Okay, we never used B, C, or D in this thing. Okay, and the next question, a block is released from the rest at the top of an incline of a slope inclined at angle of theta to the horizontal. The slope has a length of L as shown in the diagram. This is the there are no resistance forces acting on the block. What is the speed of the block at the bottom of the slope? Okay, so when the object, the block is here, it will have GPE, that is mgh, right? And as there is no friction, so all of the GPE will be changed into the kinetic energy, half mv square. Okay, so this thing is the height, and you don't have the height. Okay, we can represent the height in term of length. As you have the theta, again we can use simple trigonometry. Sine theta is equals to perpendicular over hypotenuse, this will be h over L. Just to get the option, that those are shown in the in the list. Okay, I'm just making that form. We don't have any option in term of h. Okay, if you see, so I'm just converting the h into sine theta and L to get the right answer. So h is equals to L sine theta, we can write. Okay, so we know loss of potential energy, GPE, is gain of kinetic energy. This is mgh, and that is equals to half mv square. This m and m cancel out, and you can put, you have to find v, so v will be equals to 2gh square root, and we can put the value of h here. 2gh is equals to L sine theta. Okay, still we don't have any option here. So okay, if you see, this can be written as under root 2g under root L sine theta. Okay, even if you look at the options now, you can easily judge this is the only form that we have. But for surety, you can also find the value of under root 2 and g. Okay, so okay, yes, this will give you 4.429 under root L sine theta. That is option B. Okay, in the next question, a skateboarder and her skateboard have a total mass of 70 kg. She pushes on the ground with her foot to create a forward force F that is equals to 25 newtons on herself and the skateboard as shown in the diagram. The skateboarder and the skateboard travel forward at a distance of this surf before the skateboard hit her foot from the ground. What is the word done by the force on the skateboarder and the skateboard? You just have to find the word. It's a pretty easy question. Work is force multiplied by the displacement in the direction of force, right? Force you have 25, and distance it is traveling is zero point 0.5, that will give you 12.5, nearly 13 joules. Okay, it's a pretty easy question. You just need the force and the displacement in the direction of force. Both are given. Okay, in the next question, a turbine at a hydroelectric power station is situated at a vertical distance of 30 meters below the level of the surface of the large lake. Okay, let's try to picture this thing. We have a large, let me write here. We have a large lake, Okay, this is a large lake, and water, let's suppose it's falling from here, and there somewhere we have a turbine. Let's Okay, and they have given us the height of the surface till the turbine. What is the height? That was 30 meter. So it's falling at 30 meter. Okay, the water passes through the turbine at a rate of 340 meter cube per minute. Okay, meter cube is volume and this is second. So what you have volume per second, that is equals to 340 meter cube per minute. If you see, all the options are in watts, so you have to convert this thing into SI units. So minutes will be changed into seconds. As it is per minute, so minute to second it will multiply by 60. So as it is per minute, so it will be divided by, okay, for this thing it will be 60, then it will be meter cube per second. So let me calculate. 340 divided by 60 give you 5.66 meter cube per second. Okay, so this we have, and the overall efficiency of the turbine and the generator is 90%. The efficiency, the density of the water is this. You have density of water. What is the useful power output of the station? Okay, so efficiency is also involved. So let's work it out. We know efficiency is power, useful power output divided by power input. You have to find power output. So it is P out is efficiency is multiplied by P in. So P out efficiency is 90%. When you change it, it will be 90 divided by 100, 0.90, multiply with the power input. So I need to know the power input. So let's work it out. We have the information. So power input is energy input divided by time. What energy it is taking? The water is falling from the height, right? So at height it will have GPE mgh. Okay, it's converted into the kinetic and it will hit the ground. So energy is mgh divided by the time. Okay, so what we have height, we have this thing, we know g, but I don't have the mass. But what I have the density, I have the volume per second. Okay, so I can change the mass into the density. So we have a relation, if you remember, that mass can be written as density into volume. Okay, let's write it down. Density into volume. I am just putting the value here. Okay, so it's density into volume into G into H, and T is divided. Okay, so if you see, we have the density, we have this whole thing, volume per second, where it is, there we have written. Okay, we know the G is constant, H is also given. You just need to put the values. So P in will be the 1000 into volume per second is 5.66 into 9.81 into the height, that is 30. Okay, so when you calculate all of this thing will give you 1665738. Okay, and then you will put this thing here. So you will get 0.9 multiplied by 1665738. That will be equals to 1499164.2. That is almost, if you round it off, 1.5. And how many zeros will be there? One, two, three, four, five, six. It's million watt. Okay, six zeros. So it's option B. In the next question, a projectile is launched at an angle of 45 to the horizontal with an initial kinetic energy is E. Okay, and assume air resistance is negligible. What will be the kinetic energy of the projectile when it reaches at its maximum height? So let's imagine the scenario. This is the ground. There is some projectile. It is launched at an angle that is 45-degree. As it is launched, it will move like this. Let's suppose this is the maximum height. At start, the kinetic energy is equals to kinetic energy is equals to E. Okay, and at this point, you have to find its kinetic energy. And if you see the options, its energy is in term of the initial kinetic energy. Okay, so there you need to review the topic of projectile motion. If you remember, if I say the initial velocity of projectile is u, this will be its x component, this is u cos theta, and there will be its y component, that is u sine theta. And as we know, there is no force in horizontal. This component will remain constant throughout the journey. So there will be a u cos theta acting on it. And as it is a maximum height, so the vertical component will no longer be there. So you can say, and this thing will be equals to the vx, okay, and vy will be 0 because it's a maximum height. So you can say the total velocity will be equals to the vx. So v is equals to u cos theta, okay, at this point. So if I have to find the kinetic energy at this point, it will be half mass into velocity square. So you can write as 1 by 2 m. Velocity is u cos theta. Theta is 45 degrees. It's given in the question, right? Okay, so when you solve this, it will be 1 by 2. On the left hand side, it is ek m into u square cos square 45. And if you see at the start, this energy was equals to half m u square. Initial velocity is u, right? So this thing can be called as E and multiply by cos square 45. Okay, so if you solve cos square 45, it will give you 0 0.5. So it is 0 0.5 E is equals to energy at the highest point. It's option A. Okay, that's it for today. Please like and subscribe the channel if you want to view the more videos. In the next video, we will solve the questions of 2024 papers. Thank you.